All right, in this section we're going to work on multiplying and dividing algebraic fractions. And we kind of already know, how to do this. I think we've done some of it before. We're just going to look at some more complicated scenarios. But basically, the way we multiply fractions, whether they're algebraic fractions or numerical fractions, is you multiply the two expressions in the numerator, put those on top. Put that product on top. You multiply the two expressions in the denominators, you put that product in the bottom. The way we divide two fractions is, let's say I have a over b and I'm dividing it by c over d. The a over b stays the same, but we flip the bottom over, we turn it into a multiplication problem. So dividing by the fraction c over d is equivalent to multiplying by the fraction d over c, and then we just work out the product the way we know that we're, the way we multiply fractions. If we're doing a multiplying or dividing a fractions problem, we always factor first. That is the first thing we do, is try to express everything as a product of things. We're going to start out, there's no factoring to do in this first example, right? Everything, there's no addition or subtraction, so everything is just a factor. But the reason that we want to make sure that we have everything factored is that we're going to cancel common factors. So, for example, this factor of a cancels with that factor of a. I could cancel common factors as long as one is on top and one is on the bottom. They don't have to already be in the same fraction. 5 goes into 15 3 times, and b will cancel with one factor of b, leaving me with b to the first up top. And we're left with now 9b over 1, or just 9b. Keep in mind that if everything cancels, like everything canceled in the bottom, we had no factors left, that meant that we have a factor of 1 down there. Okay, so now we're going to multiply here. Now it always says multiply, usually, that's what the instructions will say, multiply or divide. But it means to express the product or the quotient in a simplest form. So do not start by multiplying things out. You start by factoring. Now, in the first fraction, everything's already factored. We have 3 times x minus y, and then down here we have x minus y, x minus y. You could still write it as x minus y squared. I'm just going to kind of write it out as two separate factors. In the other fraction, up top we have a difference of squares, so that's x plus y, x minus y. And in the bottom, I could factor out a 3 and be left with 2x plus 3y. Okay, so now that everything's factored, we're going to whip into a frenzy of canceling. This is the fun part. I can cancel this 3 with that 3. Here's an x minus y to cancel with that x minus y. Here's another x minus y in the bottom to cancel with that x minus y up top. And now all of our common factors have been canceled. So simplifying this, we're left with x plus y up top. In the bottom, we've got 2x plus 3y. And that's as far as we can go. We can't cancel over addition. So since there are no more common factors, this is as simple as it gets. All right, let's try another one. We're going to factor first. Always factor first. So in the first fraction up top, I could take out a 2, and then we're left with x minus 2. In the bottom, I could take out a 4, and we're left with x plus 3. All right, in the second fraction, the 3x minus 1 in the bottom is already factored, right? That doesn't go any further. But I think we can unfoil or factor this top expression. To get a 2x squared, I need a 2x and an x. And then I need to get a negative 15 product. So one of these is going to be plus and one of them is going to be minus, but I need a plus x up top, or in the middle term. So you might want to pause it if you want to have a go trying to find what works before I have a go at it myself. And I think what will work is x plus 3 and 2x minus 5. Then you'll see that we have a plus 6x in the outside terms and a minus 5x inside. Now everything is factored. So let's cancel x plus 3 with x plus 3. 2 goes into 4 twice. And that is as far as this goes. So what we're left with on top is x minus 2, 2x minus 5. On the bottom, we have 2 times 3x minus 1. And that's as far as we can go. Sometimes people will continue and they'll like multiply out the product, like FOIL out the product on top and distribute the 2 on the bottom. And you're allowed to do that. It's not incorrect, but it doesn't get us anything. It doesn't make it any simpler. And in fact, sometimes, depending on what we might want to do or what we're, where this expression arises from, can make drawing some conclusions more difficult. So this is usually considered preferred to leave it in factored form. All right, now let's do some division. In this first example, there's no factoring to do, right? Because we don't see any addition or subtraction. So everything is already in factored form. I'm just going to rewrite the division problem as a multiplication problem. So we have 3a squared over 5c times, and I'm going to flip the second fraction over, a over 2c squared. And then I just look to see if I can cancel anything. Now, in this case, nothing cancels. There's no common factors on top and on the bottom. So I'm just going to multiply straight across. So we get 3a cubed over 10c cubed. And that's as far as we go. All right, so when I encounter a division problem, the first thing I do is write it as a multiplication problem. So this is x plus y over 3 times 6x plus 15y over 2x plus 2y. And then I factor. Now you could factor first and then turn it into a multiplication problem. You could do both at once. Like certainly you could flip it and factor at the same time, but I find that sometimes I make mistakes when I try to do both steps at once. So I've just gotten myself in the habit of doing one at a time. So in the first fraction, everything's already factored. In the second fraction, we could take out a 3, and then that's 2x plus 5y. On the bottom, we could take out a 2 and get x plus y. Now we're ready to factor, or to cancel common factors. 3 cancels with 3. X plus y cancels with x plus y. So we're left with 2x plus 5y all over 2. You can leave it like that, or depending on where this expression arises, some folks might split up the fraction and call this x plus 5 halves y, and either is fine. All right, let's do another one. To do this division, again, the first thing I'm going to do is just turn it into a multiplication problem. 4 minus x squared over x squared minus 3x plus 2. And then now I'm going to multiply by x squared minus 9 over x plus 2. Now I'll factor everything. In the first fraction, 4 minus x squared, that's a difference of squares. So that's 2 plus x times 2 minus x. On the bottom, we can unfoil that. It'll factor as, so we need an x and an x. We need a 2 and a 1. And they're both going to be negative. That'll give us the minus 3x in the middle and a product of positive 2. In the second fraction, we have a difference of squares up top. So that's x plus 3. X minus 3, and then we have x plus 2 on the bottom. Now I'm going to do some rewriting before I cancel anything. The first thing is to note that 2 plus x is equal to x plus 2, right? I mean, we can flip the order of addition if we want. But I have this factor of x, of 2 minus x here, right? And I'd like it to be x minus 2. That's awful close. It's just reversing the order of subtraction. So I'm going to factor out a -1. I'll write that as a -1 times x minus 2. And now we can do some canceling. X plus 2 cancels with x plus 2. X minus 2 cancels with x minus 2. And what we're left with on top is a -1, negative x plus 3, and x minus 3. On the bottom we have a factor of x minus 1. And I'm going to leave it just like that.